Hello and welcome to it. My name is Ben Porter, and I'm going to be walking you through getting a development environment set up for a Phoenix project based on Elixir. And this project is called Malan, and it's a simple user authentication service that you can plug into services ecosystems or even fork and use as the base for a future Phoenix project. But regardless, this is more aimed at people who are kind of new to Phoenix or an Elixir, who have possibly never written an application before. I'm going to assume a little familiarity with basic command line tools, but for the most part, let me walk you through getting going. Okay, so first thing you need to do if you're going to have a native development environment set up is you need to install Elixir and Phoenix. To install Elixir, the directions kind of vary. If you're on a Linux distribution, it's typically in your package repositories. So for example, on Fedora, I just do a DNF install Elixir and I'm good to go. Depending on your platform, you may need to use something different. But once Elixir is installed, then you need to install Hex, which will manage packages. Installing Hex is very easy. It's just run mix. Mix is the tool that comes with Elixir. So run the command mix local.hex. That will install it. Then to install Phoenix, there's a couple of ways. If you're using an existing application, then you can usually just install it using mix, which I'll show you in a bit here. But if you are starting a new project, then you may need to just install Phoenix directly. So here's an example right here where you can use mix to install Phoenix 1.5.8, which as of this recording is the latest version, but obviously that will not stay true in perpetuity. If your application is going to have a front-end component to it, then you'll need to install Node.js. But if you're just building an API, which in our case we are, then you won't need that. We will need Postgres. So most applications will need a database, but if you're lucky and you don't need one, then you can skip this part. But in our case, we use Postgres, which is the default. And I'm actually going to use Postgres inside of a Docker container because I find that to be much easier. And I've got a wrapper script that will run it for me. You're more than welcome to use something similar, and I'll show you the script in a minute. Or you can use the Docker Compose or whatever you want, because both are supported. They're both there. Also on Linux, I install iNotify tools, which is nice for getting live reloading when your assets change. Typically, for a backend app like one we're working on, that not something you need. It doesn't matter. But if you are doing any sort of front end with it, then it's a very nice thing to have. So let's take a look at the application. Okay, here we are at a command line prompt, and I've already got the project checked out. If you don't, you can grab it from GitHub. It's at github.com/freedomben/Malan, and you can clone it locally. That will get you these files that you need. If you want to use Docker Compose to run it, you can see here we've got Postgres in there, and it will get set up for you. And you can also run Malan itself inside of Docker Compose, which some people like to do. So first, let's take a look at the Docker file. So this Docker file is pretty straightforward. The top part here is mostly boilerplate. We're going to start with the Elixir 1.11 image, and then we're going to create a user and a group to run as, and in this case we just call them Docker. We're going to run our updates and install some of the dependent packages. This is a Debian-based image, so that's why you see apt used there. And the real work, after we set locales and things, starts to happen down here. So in this case, we're going to put all of our code into a directory called /app, and we copy it over. In this case, I'm copying mix.exs and mix.lock first because that's to take advantage of the way that Dockerfile caching works. So that way, you only need to reinstall and rebuild all those dependencies when you actually change the mix.exs file. Otherwise, it will use that layer from cache, which is really nice. And I did a video on the way that Dockerfile caching works, and I'll put a link to it below if you want to learn more about that. Other than that, these are just the steps that we use to build the application. And in this particular Docker file, we are building a development image, but a production isn't radically different. So the production version It looks largely the same. There's just a few minor differences. In this case, we've got to set a couple of dummy values to get the compilation to work, which is highly annoying and unfortunate, but it is the way it is. And then we've got to set the mix-env environment variable to be prod. And then down below, we only download and install our production dependencies, since we don't need any more than that. So, and then also our entry point is a little simpler. We just run the mix phx.server, and that's that. So let's take a basic look at the code base here. So if you're familiar with Phoenix, then a lot of this will be pretty expected for you. If you've used Rails or anything similar that kind of follows that same philosophy, then a lot of the things here will seem very familiar to you, and that is by design. If you've never used any of them, then don't worry, we're going to walk through it a little bit here. So let's look at the directories. First, we've got this config directory, and in here are some files. And I guess a quick note here, if you don't know much Elixir yet, when some of the files will end with a .exs and some will end with .ex. And the difference there is that the exs is code that's more intended to be run as a script, whereas the .ex is more intended to be compiled and run that way. So you'll see a lot of files that just have basic setup code, especially tests and things like that, that will end in this .exs. But it's all just Elixir code, so don't let it throw you off too much. So let's take a look at some of these config files. So this config.exs is kind of the top one, and you can see we put some basic values in there. And this syntax may look a little strange. This is Elixir code. Most Elixir code that you write won't look quite like this because this is meant to be very declarative, kind of a declarative style. So that's why there's no parentheses and things like that to make it very readable. But learning Elixir is a little bit outside of the scope of this video, but you can definitely, this is just Elixir code. So if you want to understand what it's doing, then you're more than welcome to dig into that. But otherwise, this is how we do basic configuration. So each individual environment, actually, flip back here. If you look at the bottom here, there's this import config function call, and it uses the mix environment to find the appropriate file. So depending on what your mix environment is, you can override certain settings, and that's very useful. So for example, this is the dev.exs config file. So here, we can set different username, password, hostname, all that stuff for our database, which makes it much, much easier to just keep things in config and not to hard code things, which we don't want to do. But for the most part, it's not a lot of stuff there, but more than welcome to look through it. Production is going to be a little bit more sparse. A lot of this will go into a secrets file. So prod.secret.exs is going to contain production secrets. And for production, obviously, that needs to be treated much differently than you do in development. But okay, let's take a look at a little bit more. So inside this, let's start with this Priv directory. So inside this Priv directory, you've got a few other directories. So get text, which if you're familiar with it, you probably can figure out what that is, and otherwise, no. It has to do with localization and languages, so you may or may not need that. Priv/templates, this is going to contain some basic templates that the generator uses to generate new files for you. What's extremely useful about this is you can change these all you want. You can basically set your own templates. It's incredibly useful, and I've used it in here to basically make it so that when I generate new tests especially, those files will come with basically the boilerplate for all of the tests that I'd like to write. So authorization and authentication tests, which don't normally come, and other different scenarios. And it also will kind of pre-generate some useful methods or useful functions for me that I can use to save some time when doing tests. So then you'll have this priv/repo, and in here are a couple import files. Seeds.exs is basically a seed script. Now, if you're not familiar with this, best practice is to have some basic data that you can inject. And sometimes you'll use this in production, sometimes not. It's really up to your application. In our case, with this application, since it is a user authentication, we run into this chicken and egg problem at the very beginning. where when we first deploy the application, there are no users. But you cannot create users and do anything with this until you are logged in. So we have a little bit of a problem there. So by default, at the very beginning on a first deployment, we will create a root user with this seeds file. And the password is set to ridiculously easy things. Obviously, in production, you will want to delete this user as soon as you're done with it, once you've got everything bootstrapped. But in development, it's kind of convenient to keep. And we can do anything else we want in this file. Right now, it's pretty straightforward, but I do recommend that you try to make this file idempotent, because you will run into a lot of cases where it gets run multiple times, and if it's not idempotent, then it can break, and it may not work when you try to run it, and it can get very fragile, and it can also do very unexpected things. So that's why I recommend you keep it idempotent. Okay, also in Priv repo, we'll see this migrations directory, and in here are where the migrations are. So if you are familiar with most if you are familiar with most frameworks for web development, if you use a database, especially a SQL database, you'll have a need to define your schema. That's a very important aspect of it. And it's very rare to define a schema that will last for forever. Almost guaranteed at some point you'll need to make a schema change after your application is deployed. So that's where migrations come in. Each migration basically just contains a little bit of code that will change the schema of the database to fit what you need. And these are where those are kept. So these files are kept in version control, and they get run before each deployment. So let's look at an example here. Be a big one. This is create users table. So this is all Elixir code, and it's a DSL it's called Ecto, and essentially there's different functions that are created to allow you to do common things. So rather than write the SQL directly, for example, we can use this create table function, and we give it a name, and we set some parameters, and then in here we can add columns to it. And there's a couple like timestamps, which is a special one. That's a macro that will expand to give us columns that automatically keep track of creation time and updated time, which is very useful, and I highly recommend you nearly always use them. And then we can also create a couple of indexes here, which in our case, we're going to want those on the username and the email column, since we will frequently query this database using username and email in addition to ID. At the very top here, there is a free-form SQL, because at least as of the time of this writing, this wasn't something Ecto provided directly. So this just uses it adds an extension to Postgres called SciText, which is case-insensitive text, and that's very useful. For example, when you are doing email stuff. So as you can see, email and username in this system are case-insensitive. And we can have that kind of done at the database level by using this SciText type, which is why I do that. Okay, so let's look at some more. In this scripts directory, I've got a bunch of scripts that are just very useful for development. Right now, they are very well tailored for myself, but for example, the start Postgres one, this is the script I mentioned that just starts my database. So I prefer to have a native development environment, but for database, I don't like to run that natively. It's nice to have a different container, so that way you can have multiple apps all coexisting on the same machine with no problems. So I just wrote this quick script because on Fedora, Docker Compose is not a super great experience. So I try to avoid it. So that's another reason I had this script, but it's very straightforward. It looks a little hairier than it really is, but it basically just starts up my container. And then these other scripts do various things. Like one of the very common things to do is to use a psql prompt. Well, being that it's inside of a container, it's a little bit different, because I can't just run psql on my machine directly. I can, but versions have to be the same and things like that. It's just much easier to use the psql from inside the container, but I don't want to have to remember to type out that command every time, so I just wrap it in a quick script here, and when I run this script, if the database is up, it just grabs me a psql prompt inside the container. So very nice. Okay, let's take a look at the lib directory. So this is where the actual code for the application will live. And we can take a look at some of these here. So in Phoenix, there's this concept called context. And it's essentially a way to kind of divide your application up in where you can keep models that are related to each other in the same place, which is nice because traditionally in a lot of applications you kind of run into this thing where a lot of these tables and a lot of these objects are highly dependent on each other, but they're kind of separate, and you try to keep them modular when you can. But this is nice. It's nice to have these contexts because you can keep things that are related to each other close together and have a little more separation for things that are less related. So in this case, I create an accounts context, and this is the only context in this application, but in a normal application, you'd have a lot more. So if we look inside this accounts directory here, you can see there's a bunch of little files, and most of these are types that we keep track of in the database. So we can take a look at some of these, and this is just regular Elixir modules, and a lot of these are just helper methods. So in this case, this application, when we're keeping track of, say, ethnicity, that's an enum type, and we want to have strict enforcement on that type to make sure that our data stays valid, especially as we're doing analysis. In this application, there's potential for, not in this particular service, but the application that this service was originally designed to be a piece of has a significant amount of machine learning in there. And it, one of the things it'll look for is trends among people, based on health data, and trends based on, things like age and ethnicity and gender, sex, that sort of thing. So that's why we keep track of a lot of this stuff here. And these are just very useful methods that make it a lot easier to kind of keep track. But and same thing with gender. There's significant more number of possible values for gender than there is for some of the other things. So you'll see they do vary in sophistication quite a bit. So this file here, this preferences file, this is just it's basically a JSON. It gets serialized into a JSON object and then stored inside the table. But unlike normal JSON inside of a SQL column, inside of a Postgres column, there's a lot of validation that takes place on this. So that's why this is in that file. But let's take a look at something a little bit more important, the application. Okay, so let's start with looking at the schema. So as I mentioned, Phoenix makes use of a library called Ecto, which provides the database interactivity. You can kind of think of it as an ORM if you're familiar with that from other languages, such as like Active Record, that sort of thing. But whereas a lot of Phoenix is very similar to Rails, you'll see Ecto is actually significantly more different than Active Record. It's very different, and I like it. I like it a lot more. I think it's really nice, but it is something to be aware of. So let's take a look at the schemas. So there's a main schema called user. So this is for the table called users, and this is largely declarative at the top here. So we basically declare a schema, and if you look at the migrations again, you'll notice that a lot of these are essentially the same kind of syntax and same things, and that's by design. But the big difference is that the migrations are a one-time thing that runs against the database, whereas this file here, this is the latest version of the schema. It's always updated to reflect. So as you're doing deploys, if you want to have a zero downtime deploy, you got to make sure that this schema file is always compatible with the schema inside the database. So oftentimes it's two migrations. If you need to drop a column or make some other change that will not be compatible, then that's something to consider. So I won't go through all of these. It's pretty straightforward for the most part. One maybe difference is if you think back to that preferences object that we looked at, this is where it gets embedded. So that's why it becomes a serialized JSON inside of a column inside this table. And then there's also this concept of virtual columns in Ecto. And the basic idea is that these are columns. Virtual column means it doesn't actually exist in the table, but it's kind of a temporary thing that we can use as we're kind of moving data around and figuring things out. So a very common usage would be for passwords. So you'd put, say, the password here in a virtual column. And you can see this is actually a virtual up here. And then the actual password will get stored in this password hash, which is a real column. But when users are creating this, the hash gets calculated by this code afterward. In fact, we can look down at some of the code that actually does that. So in the end, this password column doesn't get persisted. It will get hashed and persisted as password hash. But so let's take a look at. So here's our validate password function, and all these functions in here are directly related to the schema. We typically there's a lot of validation code in here, so validate length and format and things like that. You'll find a lot of debate in the Phoenix world about where exactly validation should happen, and what's business logic and what's not, and where's the appropriate place. And to be honest, I don't know. So I tend to follow a lot of examples that I see, and so there's a lot of the business logic is in the actual context, which we have not looked at, and we will in a minute. And then a lot of basic validation tends to be here in the schema. So here's the put pass hash function. So change sets is the argument it takes. And in Ecto, a change set just represents some delta, some piece of data that you're going to insert into the database. And so this comes in and we pattern match on it and basically say if it's valid, then this section here will run. And if it's not valid, then we just return the change set unchanged. And the basic idea is we don't want to hash the password and insert it if the change set's going to fail anyway because it's already been marked invalid by some earlier validation. So if it is valid, then we're going to add a change to the change set. We're going to set this password hash, and we just use a util called utils.crypto.hashpassword, and that is actually code in this data or in this code base. And find it here. So here's that method. And it just uses a pbkdf2 library to do a password hash with salt. So I highly recommend you use something like that, or because you don't want to be writing your own password hashing code. Okay, so yeah, the rest of these functions are pretty easy to kind of figure out what they do, depending on things. One thing that is a little bit different about this application that I don't know if anybody else has done this or similar, but I basically create this password. There's a virtual column in here for a password reset. And the basic idea is this is a virtual column, so it doesn't get persisted. But if this field comes in set, so like if the post or the put request from the client comes in and this is set, then it will end up going through this password reset process. And that will essentially generate a random password, and then it will put it into the password field. And then from there, typical password hashing will happen. And so that's how you can basically generate a random password for your user. And this is intended to be used by an admin to just kind of as a convenience method. As an admin, it's nice, to be able to do that. And also it makes it so there's potential for automation later, but some things will need to be changed on that anyway. So let's take a look at the session object. So the session is not terribly different than the user. It's just an Ecto schema, and it's got its own things. So in this case, we've got API token and API token hash, and as you can imagine, the hash is the actual column, and the API token is a virtual one. And you can set expiration and things like that. So essentially, a user can have sessions, and each session is basically just tied by an API token, and that's how the client can make calls as a particular user. So one thing to note here is there is a relationship here with this belongs to. So that just adds convenience functions that Ecto provides, which allow us to take a session, for example, and get the corresponding user out of it without having to do manual queries and things like that. But For the most part, it's pretty straightforward, pretty simple to understand. Some of this other session code down here is just generating and setting different values and things like that. So to test this stuff, we test at different levels. In this case, we've got this user schema test, and it's a very straightforward Elixir test, and it will just go through and exercise these functions as much as possible. So if you look through this, it's also typically a really good example of how to use a function. So if you're trying to figure out how you would use some function and it's not super obvious, then oftentimes you can find the corresponding test, and it also serves as documentation in a way. So not a replacement for writing actual documentation, but it's definitely helpful, and it's nice that, when you can find that sort of stuff. So yeah, look at the session schema test, or I guess there isn't one. But okay, so let's take a look at the accounts context. So this is basically the entry point to the, if you want to call it the back end of the application. So we've got controllers and other parts that are part of the web side of the application. And then this account side is kind of, this context area is kind of split in a different way, so that, the basic idea is that it could be used in a way that's not coming from the web side, in a way that's not coming from the controllers. So you kind of keep the application's context different than, you don't tie it directly to a web front end, if you will. In practice, what I found, though, is it doesn't typically matter. I'm sure there's applications where this is not the case, but at least in my case, I find that they end up kind of dependent on each other and intertwined anyway. So it's not a huge win, but you'll see functions in here, for example, that act on users. So like list users, which is an extremely easy, straightforward call using ecto. So if you're familiar with active record, this class dot method name will look familiar, but it does vary quite a bit. We'll see that in a minute here, but these are just ways to get so like to get an individual user here, this is how you would do it. And this syntax here, this from function, this is how you basically create queries. And one of the reasons I like this and ecto so much more than say active record and a lot of the other, is that this syntax, this DSL that it provides, is much closer to SQL than a lot of them are, and I really like that. For me, it makes it a lot easier to reason about it, and it's extremely intuitive. And once you've written a few of these, if you have SQL experience, then it tends to be pretty easy to translate it into ecto, and it's really quite a joy to use. So we won't go through all these functions, but there's quite a bit there, and this is kind of how users get registered and created and updated and things like that. And some of these can get a little bit complicated, but for the most part, it's pretty straightforward. So like here's an example. We're verifying the user's password. So the user, through the controller, has tried to create a session, and that from the controller gets called here, and they pass a user ID and the password the user gave and the password hash. And this function will essentially verify that. So it'll run it through the crypto algorithm that will generate the it will actually do the comparison as well. And if it fails, then we return it unauthorized and like that. This fake pass verify, this is a security measure in that I did web application security for a while, and timing attacks were amazingly fruitful. Often you could enumerate whether a user existed, even if the application wasn't set to tell you. A lot of applications will just say either username or password was wrong, and it won't tell you which one. But in a lot of these applications, you could use a timing attack, because it takes a while to go through a hash function for a password. It can take 600, 700 milliseconds. And if the user doesn't exist, a lot of times the application will just return immediately. So you can pretty clearly tell which users exist. So you can enumerate them just through brute force and guessing. So that's why this function is here. Basically, if the username doesn't actually exist, then we will still undergo the hash. So that way our timing is the same, and you can't really tell if the user existed or not. Now here we do return error and not a user, but it's up to the controller essentially, or the calling function, to do what it will with that. So mostly that just gets logged, and then we never end up telling the user what the specific error message was. So yeah, authenticate by username pass. So in Elixir you'll see lots of tiny functions, and it's kind of a style thing. If you've used languages like Java, you may be used to functions and methods that are hundreds of lines long. That's very much not idiomatic Elixir, so we tend to stay away from that sort of thing. Try to have functions that are concise and simple and easy to follow, and so that's why you'll see a lot of these. This is maybe the most complex query in this service, and basically it takes an API token hash, and it will pull all of the session information based off of that, and it does a join with the user table. And this function is written this way because this gets called a lot. Essentially, every single API call will have that API token in it, and we have to hash that token and then compare it against a record in the sessions table to make sure that it's valid. So basically, this query will do that, and it does it with what it needs. Essentially, I tuned it to where all the information we need to make basic access control decisions will get returned in this single query. That way it's very fast. It's under a millisecond, so it doesn't end up being a problem whatsoever, which is really nice. If you worked on an application where every request had 500 milliseconds to a second worth of overhead in pulling that session information, then you know how quickly that can add up to unacceptable levels. So that's what we do here. And that's probably the most complex one in this application currently. Then the rest of these are just checking for valid system or valid sessions, things like that, and try to keep it pretty explanatory. Any function that's of any sort of importance really that isn't super clear, I did a decent job at documenting, so that should be there for you. And of course there is a test for this, so it's counts test here, and you can go through and it just basically exercises all of these methods, all of these functions. And yeah, you're welcome to read through that if you are interested. Okay, let's take a look at the controller, but before we do that, let's look at the router. So the router is a piece of Phoenix that essentially takes the HTTP path and converts it into a controller. Basically, it decides who is going to handle this request. There is a concept of pipelines in Phoenix, which is really quite useful. And in this case, we've essentially used it we've got these different pipelines depending on what is required by that endpoint. So if a user needs to be authenticated or have certain privileges or have a certain role, like being an admin in order to call an endpoint, we can basically run it through these pipelines, and the pipeline will take care of doing all of that validation. So by the time it gets to the controller, we know that that is an authorized check, and that greatly simplifies our controller. Now, there are times when we can't really do that. We can't, there's either not enough information in the request or it's more complicated than that. So there are cases where it ends up not just happening here, but for the most part, the router here has a lot of that logic. So here's some of the endpoints. So we've got a simple health check endpoint, which does not get piped through anything. That is for performance reasons, since these get called sometimes a dozen times per second, so they need to be very, very fast. So then we've got this scope. So there's concept of scope in the router here, and it essentially is kind of the beginning. So all of these API endpoints will have /API at the beginning. So we basically say all of these inside this block are going to be under /API. And this block, we are going to pipe through the unauth API pipeline. So if we look back at that, all it does is just add an accepts header of JSON, and it doesn't do anything else. So these are unauthenticated endpoints. So user create is one of those, which is important because user usually you want them to sign up on their own. Now, if you don't want users to be able to create their own accounts, then you can, of course, just move this endpoint down to an auth endpoint, and then no longer will users be able to access it directly. And creating a new session, that is unauth because that's how you log in. So if you can't log in unless you're authenticated, then we've got a chicken and egg problem again. So then we've got auth API, no terms of service. So it depends on how you're using this. It was built to require you to have signed to the terms of service and the privacy policy before you can call certain functions. And if you have that enabled, then you can use these pipelines to basically say, like, for example, the endpoint to sign or accept the terms of service. You don't want that to require you to have accepted the terms of service, since, again, chicken and egg. So that would be there, for example. But if you had other objects in the system, then you may not want those to be able to be created until after you have accepted these terms of service. So that's how you can go about doing that. The rest of these endpoints are pretty straightforward. Most of these are not used. They're there because they're very useful if you're going to be expanding or forking this project to create your own. And that's actually what it was born out of, was a much bigger project, which there's evidence of that in different places. But if we look, then we could see that these endpoints are so this resources function here, you can pass like /sessions/users, and then you can tell it which controller to use and which methods in those controllers to use. So this resources one is a little bit magical, where it just generates a bunch by default, but you can also get very specific. In this case, we've got so this scope is /API/admin, and then under that, if you do /sessions, then it will forward you to the session controller and the admin index function specifically in the sessions controller. But this gets piped through the admin API first, which is going to add a header for accepting JSON. It's going to validate that you have a valid token. It's going to get that user information out of it. And it's going to check to make sure that you are authenticated and that you are an admin, meaning you have the admin role, and that you have accepted the terms of service and the privacy policy, that sort of thing. So that is the router. Let's look at the user controller. So right here, you can kind of see it's fairly boilerplate-y, especially if you used Rails. You probably recognize all these methods: the index, create, show, update, and that sort of thing. One thing that you probably haven't seen before, this plug. So those pipelines that we saw in the router, those can also be used inside of a controller, which is really nice. So in this case, with a user action specifically, it's a little different in that with normal objects, oftentimes the access control we want to check is this user an admin, or is the user themselves? If a user, like for example, a user is able to change, is allowed to change things about themselves, their own properties, but they shouldn't be changing other users. And an admin, of course, should be able to change any users. So we add this plug. This just is self for admin, and that basically checks to say, if it's the user editing their own stuff, that's fine, or if it's admin, that's fine. Other than that, it will fail. This action fallback, this is a Phoenix feature that basically, if none of these actions are correct, then there's a fallback controller, so you can gracefully fail and log it and things like that. But then other than that, these controller functions just use those accounts functions we looked at earlier. So the index endpoint, for example, will just list users, and this render will forward to the user's view, which we'll look at in a minute. And create, show, update, it's fairly straightforward. So I don't think we need to go into that. There's this endpoint, who am I, which is a little unusual. Basically, you can take an API token and you can figure out the identity of the owner of that token, which is very useful in a microservice architecture. And other than that, it's pretty straightforward. There is a test corresponding to the controller. So here's the user controller test. And as you would expect, it just exercises all these endpoints. So in this case, the request will go through the router and through the controller and all the way through the application and back. So the only thing that it doesn't really test is kind of like outside of the application itself, but it tests the bulk of the path. So that can be very, very useful. So let's look at the user view. So this is what gets rendered, and the views are very straightforward. We essentially pattern match in this render function. So there's multiple definitions of it, but you can pattern match on this first argument. And it basically just gives you a way to kind of template, if you will. There is a concept of templates, but we don't use them in the API side, since it's a lot more trivial to just render JSON than it is to render a big HTML page. So oftentimes the view in an HTML application is just a window into the template. In this case, I just render the JSON directly because it's very convenient to do so. And it basically, you can really think of this as an allow list for what should go back to the user. So by default, nothing will go. It'll just render an empty object, if you will, and but you can add anything that you want. So you can see there's some flexibility. In a lot of cases, we just take the exact value from the column and just dump it straight into the JSON. So it's a one-to-one. But in other cases, we don't. Like for example, with ethnicity. In the database, it's just an integer. It's an enum, and so we don't want to return ethnicity 7 to the user. That's an internal implementation detail that the user shouldn't care about. What we want them to see is the corresponding string, which is descriptive. So we just use those utility methods that I showed you earlier to basically take the enum integer value and convert it to its string, and then return it. And in the case of some of these more complex things, so like terms of service accepted. So we don't actually keep track. There's no column for TOS accepted, but it's very useful to have it in the JSON so that the client can figure out what's going on. So we basically will just get the latest version that's been accepted for the terms of service, because they could change. And if that's equal to the current version, then this user has accepted our terms of service. So if new terms of service get published, for example, this will automatically start returning false until the new terms of service are accepted. That's often what we want. So these can be complex if you need them to, but typically they won't be. So pretty straightforward. So that is kind of an overview of the Malan code base. Let me show you how to run the app. That would be useful. So we use Mix. If you're familiar with gem or bundle or npm or yarn, then it's basically the same thing here. So we've got mix.deps.get, which is basically going to download all of our dependencies based on what is declared in that mix.exs file. In this case, I've already got them, so it's fine. If we want to start the server, so we're doing development, then we can run this mix phx.server file, and it will compile the code if there's things that need to be compiled first, which in our case there is. And once it's done, it will execute the mix task, which will be start the Phoenix server. And then you can hit it with your web browser or curl command or whatever it is that you need. All will be well. You can also run tests this way. So mix test is how you would normally run it. You can also run only specific tests, which is incredibly useful while you're doing development. So like for example, when I was writing the user controller tests, I was running commands like this all the time. Basically, I say only run this one file and only the test that overlaps line number 34 in this case. And that is extremely convenient. So you can do that, or just mix test will just run all of the tests. So it's very useful. And in this mix.exs file, you can also add your own tasks very easily. So I created one that's not so creatively named, ecto.create.migrate, and it just runs an ecto.create and an ecto.migrate. And I find that to be really useful for development on other services that are dependent. So in development, you don't want the other user to have to care about your migration. So I basically just run this at the beginning, and it's idempotent. So it'll just run when you first bring up a container that has it in there. And if it needs to do those things, it will do them. Otherwise, it's fine. This is also an example why you want your seeds file to be idempotent and all of your migrations to be idempotent. Okay, so our Phoenix server refused to start. Now I remember that this particular computer only has Elixir 1.9, but it needs 1.11, so I'm not going to be able to run it for you in this case, but trust me, it would normally work. So that is basically a walkthrough of the Malan code base and kind of how it works and how to get started. So let me know if you have any questions, and I will talk to you later.